Hi guys, so we're continuing with the series on topics that don't usually come for CSEC Math, and we're still in January 2019, paper 2. We're doing question 5, part B this time, which has to do with statistics, specifically on the topic standard deviation. So we have a table showing the results obtained by 200 boys and 250 girls on a Spanish exam, and the table is incomplete. So we have grades 1 through 5, and then we have total number of boys, total number of girls, and their respective standard deviation. So for part 1, for 1 mark, we have to determine the probability that a girl chosen at random achieves a grade 1. So if you go up to the table, the number of girls who achieved a grade 1 is 62, and the total number of girls is 250. So the probability will be 62 divided by 250. So using our calculator, if we just divide that, we will get 0.248 as a decimal. And if we want to express it as a fraction, it will be 31 over 125. Okay, so that's for 1 mark. So part 2 for 2 marks, what percentage of the boys who took the exam achieved grades 1 to 3? Okay, so going back up, so the number of boys who obtain grades 1 to 3 is missing, but we do have the number of boys who obtain grades 4 and 5. So to obtain the percentage of boys who gain grades 1 to 3, we just take 38 and subtract it from 200, and then find the percentage of the boys who gained grades 1 to 3. So first, we subtract 200 minus 38 is 162. So 162 boys, right, gained grades 1 to 3. So the percentage of boys who gained grades 1 to 3 will be 162 divided by 200 multiplied by 100. All right, so that will be 162 divided by 2, which is 81%. And the last part, part 3, considering the standard deviations in the table on page 18, compare the performance of the boys and girls, and this is just with 1 mark. So going back up to the table, so the standard deviation for the boys is 8.2, and the standard deviation for the girls is 6.3. Now, the lower the standard deviation, it means that the grades are pretty close together. Standard deviation means the deviation of the individual values from the mean, right? So 6.3 means the grades are not as spread out, all right? The larger the standard deviation, in the case of the boys, 8.2, means that there is a wide spread of the values from grades 1 to 5, okay? Because if we were to calculate the number of girls who gain grades 4 and 5, right? So let's add 62 plus 75 plus 90, that's 227. And if we take that away from 250, that's 23 girls obtain grades 4 and 5 compared to 38 for the boys, okay? So remember, this would have been 162 boys obtain grades 1 to 3, that is 81%. So if we find the corresponding percentage of girls who made grades 1 to 3, of course, grades 1 to 3 being the better grades, then that's 227 divided by 250 and multiplied by 100. That gives us 91%. So this shows us that the girls did perform better than the boys because a greater percentage of girls gained grades 1 to 3 than the boys, right? So to sum that up, we can see, I'll type it out. Alright, the standard deviation for the girls is smaller than for the boys, which indicates that there is a smaller spread of grades from 1 to 5. Also, 91% of girls gained grades 1 to 3 as opposed to 81% of boys. So generally, girls performed better than the boys. Okay. So that is enough evidence to compare the performance of the boys and the girls, also considering the standard deviation, right, to get that one.